Hello, class. Chapter 9, Section 3. I don't know if I should be doing this, but I'm recording yet another video. This is well before it actually will be required for you to watch. It's getting late, and I'm tired, but I'm trying to get these done. I don't think I'll get the next section done after this. I'll be happy to get this one done. So hopefully this is coherent. Um, so let's begin. Law of sines. We have two things to do, law of sines and law of cosines, and then we're actually done for the year. How exciting. Um, and the problem that we face when we solve triangles is that sine, cosine, tangent, Pythagorean theorem, all of those require you to use right triangles. None of those work outside of a right triangle, and a right triangle is a very specific type of triangle, a triangle with a right angle. So we are going to look into how we can solve triangles um, even if they're not right triangles. Now remember, solving a triangle is when you find all 6 pieces of information about it, 3 angles, 3 sides, all of them. We know it all. Then we consider that triangle solved. If you remember from section 1, I was saying that you need to know 3 pieces of information to find the other 3. So you can't be ever given less than 3 pieces of information, even though when we were solving right triangles, they were giving us 2. What looked like they were giving us 2 if you weren't carefully looking at it. Well, that's because the third piece of information was the right angle. Typically, would be the so you always need to be given 3 pieces of information to find the other 3. Now, not all 3. They can't give you 3 angles and say find the 3 sides. An angle triangle will not be solvable because there are actually an infinite number of triangles of all different sizes that could all have the same angle measures. So so it can't just be any 3. It has to be specific set of 3 pieces of information. But before we get into that, all of that, how we're going to solve these, we actually have to figure out what law of sines is. So in the last section, we learned that the area of a triangle can be given with 1/2 times side B times side C times sine of angle A. And we also know that the area can be given the same triangle. The area can be found if we take 1/2 times side A times side C times sine of B, right? So let's say, for instance, you knew all 6 pieces of information in this triangle. You knew all 3 sides, you knew all 3 angles. Well, you could use either one of these to find the area, and they will give you the same area. Does that make sense? Well, if that's true, if those areas are equal, or you could actually use all 3. Sorry, there's 3 different formulas. You can pick any 2 sides and the included angle, and they all will give you the same area because the triangle only has one type of area, right? Or one answer for the area. Well, that means that all 3 of these can be set equal to each other. Like they would all be equal, right? So what I have here is I took all 3 of these and I set them equal to each other, which would be true because they're all equal to A. So they're all equal to K because we replaced the area of a circle with K, so it doesn't get confused with angle A. So it's true that 1/2 BC times sine of A would be equal to 1/2 AC times sine of B, which is equal to 1/2 AB sine of C. They would all equal the same thing. Well, these all can be multiplied by 2, and we would just do that to make them a little bit simpler to look at. Because if they're all equal to each other, now treat this like an equation. It's a 3-part equation, and we can multiply each part, so each side of each equation, by 2 and keep it balanced, right? Does that make sense? So I'm multiplying through by 2, and so BC sine of A will be equal to AC sine of B, which is equal to AB sine of C. Okay, everybody with me so far? And now we're going to do it again. We're going to do something, but we're going to do it to each part of this equation. So it's like doing something to each side of the equation, but we just have a third side that we have to do it to. And we could divide everything by ABC. So AB and C, whatever that is, multiply those together, because we know all 3. that number, we can divide all of them by that. So we have to do it we have to do it here, we'd have to do it here, and we'd have to do it here. Okay? Makes sense so far, hopefully? Well, then that means that this would simplify. The BC's would cancel out. And then the A and the C would cancel out here, and the A and the B would cancel here. And we're doing this because this actually, oh look, I canceled them out. How nice. This would actually simplify to sine of A over A is equal to sine of B over B, which is equal to sine of C over C. Now remember, that is for a triangle set up where angle A is opposite side A, angle B is opposite side B, and angle C is opposite side C. But this is true that sine of A divided by sine of, let me say it this way, sine of angle A divided by side A will be equal to sine of angle B divided by side B, which is also equal to sine of angle C divided by side C. Now you'll never do, when you're actually using this, you'll never use a three-part equation like this, but because this is true, you can pick any two of these out and set them equal. So maybe you want this one and this one, and you'll use that. Or you want this one and this one, and you'll use that. But you won't ever use all three. Hopefully that makes sense. So ultimately, the law of sines is the possibilities of matching any two of these three. So the law of sines is sine of A over A is equal to sine of B over B. Sine of B over B is equal to sine of C over C. Or sine of C over C is equal to sine A over A. Or, you could... So, and then actually, yeah, so like if you needed to solve any part of this and you had the other three pieces of information, you'd know how to do that, hopefully. So, are you ready for an example of law of sines? So, we have a triangle here, and just like I was saying, you need to be given three pieces of information, and you can find the other three pieces of information. We're asked to solve this triangle. Now, notice this triangle is the first triangle I'm asking you to solve that is not a right triangle. How exciting. But what we want to do is we want to find all three angles. We know two, so we want to find one angle, and we want to find all three sides. We know one, we need to find two sides, okay? So let's start off by, like I said, I think I always start with finding the angles, and in alphabetical order, we know A and B, so we're looking for angle C. Pretty easy to find angle C. Hopefully this isn't a problem. Triangle, have to add up to 180. So we take 180 minus the other two angles, and we get angle C is 65. That's an exact answer, so it's completely reusable, okay? No problem reusing that. So how do we find side B and side C? I'm going to start with side B, okay? If I know 50, this value here, and I know A, okay, I can use the law of sines that uses A, and so sine of 50 over 12, okay? And if I'm looking for side B, I'm going to match that up with this part here. So sine of 65 is equal to what I'm looking for, okay? So sine of 65 over B, so angle B over side B, is equal to angle A over side A. And I know A, I know side A, I know angle A, I know angle B, I'm looking for side B, and I'm solving this for B. Okay, that's all. So I have three pieces of information to put in here, and I'm solving it for the one that's missing. Solve that by cross and multiplying. B times sine of 50 is equal to 12 times sine of 65. Sine of 65. Okay, and then I'm going to divide both sides by sine of 50. Okay, and then put that in your calculator. So let me just show you. Just be careful. I would probably do 12 sine of 65, get a value, that's the numerator, divide that by sine of 50. 14 rounds up to 0.2. How cool. Okay, so now I found this value here, and it is an approximate value, okay? So we want to avoid using this unless we have no other option, right? But we do have other options, so we still have the sine of 50 and 12, so we can use that to find C. And we cannot avoid using this angle, though. That's unavoidable, because we need something here to find C, and using the law of sines, we would have to use this angle. Well, that's not approximated anyway, so it's fine. So there's no compunction against using that, but I did say don't use things. In case you miscalculate this, don't use, well, you can't avoid it. You have to use it. You do not, and you should not, use sine of 65 over 14.2. You need to avoid using that because we don't need to. We can use this. We can go this way. We don't need to use this. Even though we know it now, we should not use it to find this way, okay? So sine of 65 over, wait, this is 65. I didn't write it down. This is actually an isosceles triangle. Threw me off for a second. So we know this is 65, so sine of 65 over what we're looking for is equal to sine of 50 over 12. Cross multiply, we divide by sine of 50, and we get 14.2, which actually makes sense because it's an isosceles triangle. So if these two angles are equal, their opposite sides will be equal. Properties in geometry. But that's not going to usually be the case. Most of the time it'll be 3 different angles, measures 3 different side lengths. So voila, we found the 3 things we were missing. How exciting. So here's another one. Solve the triangle if B is 30 and C is 70 and B is 10. So angle B is 30, angle C is 70, side B is 10. Draw a sketch if you're not given it. You can just draw any sort of triangle. It does not have to be realistic size-wise as far as angle measures and side lengths go, because you don't know what they're going to be, so who knows what's going to look like. Just draw it for visual aid if you need it. So we know angle B and side B. Okay, so that's the part of the law of sines we're going to use. We're going to use sine of 30 over 10. That's gonna be the one we use. But we're going to start off by finding angle A, because I like to find the angles first. That's going to be 80. So 30, 70, 80. That makes sense. Find side A. So sine of the 80 degrees that we just found, we can use that. It's exact. Over our unknown is equal to sine of 30 over 10. Cross multiply, divide by sine of 30. Put that in your calculator for 19.7. So we have one more side to find. We found A, we need C. So sine of 70 over C, and we use the sine of 80 over, sine of 30 over 10. We're going to use that again. We're going to cross multiply, divide both sides by, if I'm going too fast, please just pause the video. Pause the video, rewind, whatever you need to do. And so cross multiply, divide by sine of 30, and once again, we find these sides. So, law of sines. Good stuff, right? Good stuff. So there is something that comes up with this that can be problematic. And that is when you're given 2 sides. So the 2 examples we did, let me just jump back here to part 1. The 2 examples we did, we were given 2 angles and 1 side. That is nice. Whenever you're given 2 angles and 1 side, you have a very fixed and determined triangle, because the angles, the 2 angles given will always give you a third angle. Will allow you to find a third angle. Right? There's no question on what that is. There is if you're given 2 angles and a side, you always have 1 triangle that it creates. There is a problem when you are given 1 angle and 2 sides. So if you're given 1 angle and 2 sides, what could happen is, and the angle that you're given is not between the 2 sides. Okay, so this is what you call the ambiguous case, and in geometry you might remember doing side angle side, side side side, congruency of triangles. Well, this is a situation that you could not use to prove 2 triangles were congruent, when you were given 2 sides and an angle that was not between those 2 sides. One of 3 things can happen when you're given 2 sides and a non-included angle. You can either have no triangle, you can have a triangle like normal, or you could possibly have 2 triangles. I did not check this link out. It's not set to I don't know if this is going to work. It would be nice if it did. Click here to install Java. I'll have to check that out later, I guess, to hopefully show this. Oop, I'm not installing Java. That's not happening. So unfortunately, that link probably no longer works because it has been several years. Yeah. Hopefully I can explain this a little bit better, or maybe I'll include a different video. I'll try to find a video and include it. So here's the case where, well, this will happen algebraically if you have a case where no triangle exists. You're going to solve the triangle, and you're given side A, which is 5, side C, which is 12, and angle A, which is 30. Now you'll remember that if they gave us the included angle, it would be angle B, because included angle would be the angle that's opposite side B, and so it would be between these two. So whatever two sides you're given, the included angle is the other letter. So this tells us, without looking at the image, without sketching it, that A is not between, or the angle they gave us is not included between the two sides. So this is the ambiguous case. If you sketch it out, how that looks is you have side here, and then this angle is not given. It would be one of these angles are given instead. This would be the side angle that would be a good angle to get, so we avoid the ambiguous case. If they give us one of these two angles, it's the ambiguous case. So we don't know to start. You won't know to start off. I'm telling you that this is a no triangle situation, but you won't know that. You'll have to go through the problem and find out. I'll show you how you find out. We're going to do the law of sines. Now, unlike the other two examples we did when we had two angles and we're solving for a side, in this case we're going to have two sides and an angle and solve for an angle. So to set this up, we have A and A opposite each other, so that allows us to use law of sines. So sine of 30 over A, and then we're looking for the side C. Okay, sorry, angle C. We are given side C. We're looking for angle C. We can't find B yet. I see I failed to label this down here, but we can't find B because the only way to find B in this case is to know what these two angle measures are, or to know what the side is opposite it. But we don't know that. So what we have to do to find angle B is find angle C. Then we can do 180 minus those two to find B. This is not a right triangle, so we can't do any trig function to find angle B. So we have to find C, and we can find C because we know its opposite side. Okay, and we can use the fact that we know this angle and its opposite side and use the law of sines to find that. So in this case, I'm going to multiply 12 by both sides to solve for C. So we're trying to isolate sine of C first. Just flipping it around. And so sine of 30 happens to be the one that, if you do this, I don't know if you remember that table. It's 1/2. Often, most of the time, you won't get an exact value. 30, sine of 30, cosine of 60. Tangent 45. So there's certain ones that'll give you 1/2. Those are the only ones, though. Very, very specific cases. But that's kind of nice here. So we have 6 over 5. So what we're solving for this for C, but we're first solving it for sine of C. And then once we get sine of C equals something, we can do sine inverse of both sides. So then I'm going to come here and I'm going to do sine secant 6 divided by 5, and I get an error, which this little thing means does not exist. So that is because this is no triangle. So when I get an error, when I go to find sine inverse, that tells me that there's no triangle. Okay. What's happening here is sine never goes above 1. But yet, here, we're trying to find sine inverse of a number that's bigger than 1, 1.2 here. So that's what's going on. And actually what's happening is the angle, so 5 is 2. So this angle measure here, this is so hard to show without a visual. This angle measure here is making this side go up. These two sides separating them so much that this side right here is actually too short and will actually, maybe we can do this here. So this side here is actually too short and will never reach it. Oh, this works pretty well. That's what's happening. But these two sides are separated by this angle measure, and this side is extended a certain amount that prevents it from getting any closer. I don't know if that makes sense. And so if this was 5, it would be swinging like this, and no matter where you tried to put it, it would never reach it. And that's why these 3 combination of measurements will never make a triangle. Now, I don't want to leave that way for future classes. So that's what's happening. Now, I didn't know that when I sketched this, because you won't know. I won't tell you no triangle. Just start the problem. So here's the case. This is the case. I'm going to change the measurements, or I'm going to change one measurement, just A. So this is the case where it makes one triangle. So just to recap, when you're solving for the angle and you get sine inverse and you get an error on your calculator, or you see that it's going to be an error on your calculator, that's how you know there's just no triangle. So this is a situation where I'm extending A so it's long enough. So this will make so A is now going to be long enough that I can reach the other side. And I don't know that's a start again, but I will find that out as we go. So again, 30, 12, but A is much longer now, so has no problem reaching. So we're going to start off this the same way, though. We have A sine of 30 over 20. Sine of 30 over 20 equals sine of C, the angle I'm looking for, over 12. Okay, and again, I'm finding C because I can't find B, not knowing either of these pieces of information. I'm trying to find this angle so I can find this angle. So I multiply both sides by 12. Again, 30 is nice. It's 1/2. So I have going to have 6 over 20, which is 3/10. So I'm going to do sine inverse of 3 over 20. That you should see off the bat that that's a lot better, because 3 over 20 is less than 10. Sorry, less than 1. It's 3 over 10. Sorry. 3 over 10 is less than 1. And I get an angle measure of 17.5, approximately 17.5. Very good. So here's the thing. When you have the ambiguous case, though, you have to always consider the second quadrant solution for this sine inverse. So when you're doing sine inverse, and when you're doing it in the area situation like we did in the previous section, or you're doing it here, you have to consider both it and you don't have to do the whole reference angle thing anymore. We're through that. But you have to consider it and 180 minus it, so that you can consider it and its reference angle partner. Okay, because both of these angle measures, and the reason we have to consider both of those, because we're looking for two. Your calculator can only give one answer out, right? So when you put sine inverse of 3 over 10 in, it's going to give you one angle measure. But that, remember, and this is what we spend a whole, hopefully you remember, whole chapter on trying to learn, was that that just because your calculator gives you one answer out doesn't mean there's only one solution. So there's actually 2 sine angles between there's actually 2 angle measures. There's actually going to be an infinite number of angle measures that you can plug into sine and get 3/10 out. But we're interested in 2, okay? That's not quite 0.3. 3 over 10 is 0.3 because 17.5 is rounded. So then sine of 62.5, okay? See how that also gives you, so there's an infinite number of angles that you can plug in, and there's, they have coterminal partners that you could also plug in. Why are we only interested in these 2? Well, remember that triangles angle measures can only be between 0 and 180. They can only go up to 180. So anything beyond 180 is irrelevant to us, and obviously you can't have negative angle measures. So we're only interested in angle measures between 0 and 180. And sine inverse has 2 of those in the first and second quadrant, okay? So whenever you're taking the sine inverse, here's what you got to do, is just you got to remember, sine inverse, there's 2 solutions. Sine inverse, there's 2 solutions, okay? It's only when you're doing the inverse. So the question is, so we definitely have one triangle, the 17.5. So whatever your calculator gives you will always be a triangle, okay? Yeah. the question is this a triangle? 162.5. And here's how we find out. Well, remember, all three angles have to be less than 180. So if this plus the other angle given is greater than 180, then we have a problem. Okay? So sorry, got distracted. Okay, so so I'm jumping down to here and saying no triangle. So what I was trying to explain was that if 162 plus 30 is greater than 180, then we do not have a second triangle. So 180 minus 30 minus 162.5 is negative 12.5. So there can't be, this angle here cannot create a triangle. Okay, the 17.5 definitely does create a triangle. Okay, so that is, you still have to find angle B and side B for this angle measure here. So we have to solve the triangle for that case, and that's what I'm doing right here. So if angle C is 17.5, find angle B and find side B, and that's what I'm going to go through. And there's no way that 162.5 can be a triangle because this is just a one triangle case. Okay, so hopefully that made sense. So now I'm going to go through and I'm going to do two, so branching this off into two things here is what's going on. So now 17.5, I'm going to find B. I can find that by subtracting 30, which is the other angle we knew, and what we found from 180, get 132.5. To find side B, so I'm just going to scroll back up. So now that I know this here, I can find side B by setting sine of 30 over 20 equal to what we found, sine of what the angle we found, the measure we found, 132.5, over what we are looking for. Okay? Cross multiply, divide by sine of 30, put this in your calculator, and you get 29.5. Okay? So when you don't get an error from the sign, you always have to solve the triangle for the angle measure your calculator gives you. And then you have to see if the other 180 minus what your calculator gives you makes a triangle. In this case, it does not. If it did, you'd have to do this entire process again, and we will do an example of that in a minute. You have to do this entire process again using that angle measure and finding the other angle you'd have, and then the other side you'd have. So it's two separate triangles, and we're going to do that right now. So what's going to happen here is triangle. We're going to have triangle with A is going to be 10, C is going to be 16, and angle A is going to be 30. So I think they did change C also in this case. So here's what's going to happen. I'm just going to explain what happens with this off the bat to hopefully help you understand what's going on. So again, this angle side is a fixed length. That's what we know. We do not know B. This angle side down here we don't know. This angle measure is also fixed. Now remember the first thing we looked at, this side wasn't long enough. It was too short to reach down because this side is fixed. It's hanging side here. Well, in this case, it's long enough to hit, and it's long enough to hit twice. So if this side would swing, what's going to happen is it would hit here. It could hit here, and it could hit over here. So it's going to actually be able to make two triangles. Like if you imagine this side not changing lengths because of my mouse, I'm just swinging. So it's going to be able to hit twice, and that's the problem. It creates two triangles, and we need to find the measure, or we're going to have to solve it for both those triangles. What's going to change? The only thing that's going to change, well, not the only thing. There's going to be three things that are different for both those triangles. The things that aren't going to change are the three things that are given. But if this was swung over here like I had, that's going to be a much smaller side. The angles are going to be different than here. So again, we set it up. Sine of 30 over 10, that's what's given. Cosine of this angle over 16. We cross multiply. We evaluate and solve. We get 4/5. Sine inverse of 4/5. Put that in your calculator. I don't think I need to do that again. 53.1. We wanted, because we did a sine inverse, we needed to do 180 minus 53.1, 126.9. Now we know 53.1 is always going to be a triangle if we don't get an error there. So let's go ahead and solve that triangle. So I'm doing if C is equal to 53.1, then the angle B would be 96.9. Okay. So now we have the third angle. I'm going to do sine of 30 over 10. Always use the 30 over 10 because we know those exact. So sine of the angle measure we just found over the side. Remember to use answer. Make sure you use the decimal value that your calculator gives when you plug it in here to evaluate. Don't. So what I'm trying to say is, so I did, just to show you here, sine inverse of 4/5. See, now I have this decimal value here. And I do 180 to find the other angle. I'm doing 180 minus 30 minus second answer is what I'm asking you to do. So that I have this angle measure here, which I wrote down as 96.9. Sounds like a radio station. That angle measure is actually more exact on here, and I want to use this. I don't want to put 96.9 in my calculator. So then I'm going to, when I go to solve this, let me just go down here. So I cross multiplied and then divided both sides by 30. So I'm going to do 10 times sine of second answer. Okay, and then I'm going to do divided by sine of 30, and 30 was exact, to get 19.85, which rounds to 19.9. But you got to be careful and use exact, or use the calculator's rounded, not just one decimal place. Okay, so I just solved this triangle for if the angle C was 53.1. But we also have to consider 126.9. And unlike in the last example, when we take 180 minus 30 minus 126.9, we get 23.1. So this is a legit triangle. Okay, so this actually works. So what you'll have to do in here is probably have to go back to do the sine inverse of 4 over 5, unless you want to scroll up, or if you stored this value, and then do 180 minus that is what you got here, 126.9. Okay, so then I'm going to do 180, and now I'm doing this down here, 180 minus 30 minus second answer. Again, second answer is your friend to get to 23.1. Okay, so now I have my B. I can find sine of B, I can find side B. Sine of 30 over 10 is equal to sine of the angle measure I just found over side B, and that's what I'm solving for. Cross multiply, divide. On your graphing calculator, make sure you do 10 times sine second answer. Hopefully I'm emphasizing that enough. And then sine 30, which actually is 1/2. But it's okay. Put it in your calculator. So you'd multiply it, end up doubling it, because division of 1/2 is the same as times 2. Whew, fun stuff. So this is called the ambiguous case. It only happens when you have side, and an angle not between the two sides. Now, I will say you should realize that this is happening whenever you take sine inverse. Okay, sine inverse is the problem that causes this. Okay. All right. So example 3. Can you believe we're only on example 3? Is that right? Oh yeah, example 1 and 2, and then I guess I didn't call this example. I called these cases. Yeah, well, you know. Okay, so this is example 3. Here we go. When an angle of elevation of the sun is 62 degrees, I drew an image here. Telephone pole is tilted, so it's not sticking straight up. So that means we can't use the, it's not a right triangle. By an angle of 83 degrees, leading away from the sun, casting a shadow of 30 feet. Approximately what is the length of the pole? So we just have a triangle. It's just a word problem for a triangle here. And it's not labeled in this case. But we don't have to solve the triangle anyway. We don't have to find all of them. We just have to find this side here. Okay. But what would be useful is to know this angle up here, because then we could do the law of sines, and because we have opposite, we have this one side we know, the one thing we know on the side, we'd have the opposite angle of it. So but we can find that pretty easily. 180 minus these two angle measures gives me 35. So I can do sine of 35 over 30 is equal to sine of 62 over x. Oh, I did it. So sine of 62 over x is equal to sine of 35 over 30. Cross multiply. So I have x times sine of 35 is equal to 30 times sine of 62. Divide both sides by sine of 35. And put down your calculator, you get 46.2. Pretty cool, huh? That you can do that. Finding that side length, and it's not even a right triangle. So cool. Okay, to find the, so here's a long problem. Let me get a drink of water before I begin. To find the distance between 2 points, A and B, that are opposite sides of a river, a surveyor picks another point on the same side of the river as A, then measures the distance from A to C. The distance between A and C is 240 feet. He also measures angle BAC to be 62 degrees and angle ACB to be 55. Approximate the distance from A to B. So that's pretty hard to imagine, but let's draw a picture. So here's my river. Here's a little fish in the middle of the river. It's a goldfish apparently because it's gold and swimming into the left. And we have a river here with little waves and what am I doing? Okay. Oh wow. Yeah. It's late. And grass. Look at the grass. I'm just admiring my picture. So what happened was he measured angles. He couldn't go. The surveyor could not get across the river apparently. So he plotted 2 points on the same side of the river. And, well, he wanted to find distance from A to B, but he plotted another point on the same side of the river. He measured the distance between those 2 points and the angle from that distance here to it, to the point across from both sides. Okay, so he found these 2 angle measures and this side. And from this, he can actually calculate the distance from A to B without ever going over there. This is actually used in the real world a lot, in construction and stuff. You'll see, like, sometimes they have these things set up along the road, and, well, they have things along the road to count. But for construction, road construction, they have to do stuff like this. I don't know the details. I can't think of it right now. I'm too tired. So we can find angle B by taking 180 minus these 2 angle measures, and we get 63. That's easy enough to find. Now we can use law of sines because we know 63 and 240 are connected, and we're looking for the distance from A to B, so we can find this measure because we know that this is 55. Okay, so to find side C, this would be side C, it's opposite angle C. We do sine of 55 is over what we're looking for is equal to sine of 63 over 240. We cross multiply, we divide by sine of 60, plug that into your calculator, and get 220.6 feet. Pretty cool stuff. So hopefully this wasn't too incoherent to this video. We have one more video to go, but I am not recording that tonight. So it'll, I'll be, doing that another day. So hopefully this made sense, and if you have any questions, please let me know. Again, you might have to, if I went too fast at any point, please. It's nice about the video. You can pause it. You can rewind. Law of cosines is next. I will be recording it another day, so I'll be wearing a different shirt. Thank you and good day.